Hello, everybody. Thank you. My today's speech is about the current state of artificial intelligence, the frontier. When we speak in about scientific auditory, of course, it's not some artificial mind. You know, it's rather it's the area of field of science and technology, which is focused on automation of intellectual problem solving. So if we have some problem that we are solving using our intelligence, and then we create some technique that will automate the solving of such task, it will be definitely artificial intelligence. So, you know, these definitions look maybe very ambitious because, you know, when the field was started, the term was coined in 1955. 1 year before the Dartmouth conference, and it was very romantic times, you know. 2 years later, the first satellite was launched on the orbit of Earth, and a lot of people that time was completely sure that maybe in 20 years we will start our moon base, and in 30 maybe we will launch our probes to the nearest stars and so on. But you know that we don't have such a huge progress in space exploration. But in artificial intelligence, of course, there was a lot of optimism at the beginning of those times, and the situation when the distance between creating the program that could beat a grandmaster in chess and creating a universal intelligent system able to solve any intellectual task that is like human mind. The distance probably at that times was estimated like few years, not more. But you know that we already have programs that could beat grandmasters and world champions in chess and Go and any board game practice. But we still don't need a system that is that could pair our minds in flexibility, our brains in flexibility. So anyway, you know that AI technologies are they are really like any other technologies, because, for example, we don't have, you know, claws like tiger claws, but we can create swords or knives, and we don't have something like huge fur, but we create clothes. And finally, we have some limitations of our brain. Logical systems with their own limitations, and we need to create tools to extend the possibilities of the human being. Intelligence, of course, we have at least two poles, two sides, I think. The first one is a weak, narrow, applied artificial intelligence. It's about systems that are very narrow, that is some particular task. It's like chess program. It could play chess. It could not see cats in photos. It couldn't play poker. It even couldn't play chess with a non-standard board like 9 to 9 squares. It only can play standard chess. But due to this narrowness, it could solve some particular task much more efficiently than our brains could do it. You know that in nature there are a lot of very primitive organisms that could overpower us in some particular task, like bee could find the optimal route inside the beehive much more efficiently than you could. But your brain is consisting in about 86,000 86 billions of neurons, but the bee's brain, bee's nervous system only consists of several hundred thousands of neurons. So anyway, it can do something better like you, even in intellectual area. Our narrow AI systems really the same. Because you know that we still couldn't pair with the computation power of the human brain with our electronic systems. But anyway, we could solve some tasks much more efficiently that the brain could do it. The other side of the artificial intelligence is a way towards universality of the systems, more general systems that could solve not only one task, but a huge set of tasks. The term was coined for this is artificial general intelligence, so it's about generality of such systems. Of course, when I was maybe in 10 years ago, when reading such lectures, I usually say that every system created by us in the area of artificial intelligence is narrow AI systems. But you know, due to transformer revolution, due to generative AI systems, we now have some systems that make some steps in the direction of the artificial general intelligence. So it's really interesting that a lot of very serious guys from serious technical institutions speculating about creating artificial general intelligence in the next few years. So we will discuss some of such claims. But back to definitions. You can see the original definition by Mark Gubrud. It's from his work Nanotechnology and International Security. So you see almost 30 years ago, this term was coined. Of course, at that times, the distance from our current technology to the AGI was really huge. So it was very, I think, theoretical definition, just to point the direction of the development of AI systems. Also, we have some modern definition of artificial general intelligence. It's from James Seligman book, and it's very common. You know, usually it's like in Wikipedia, we also have such a definition. So AGI is an artificial intelligence capable of performing any intellectual task a human can do. What's wrong with this definition? And of course, we can ask questions about literally every part of this definition. Because, okay, AGI is an artificial intelligence capable of performing any intellectual task a human can do. Which human? because is it maybe average human, or maybe it's the best human in the world for such particular task. Maybe we have some task that could be solved only by one guy in the whole world. Is it necessary for our system to be able to solve such a task, to be called AGI? So within which time, energy, or value limit to solve such task? Because, it's very easy to write a chess program that could find the best moves. Just search through the whole game tree and pick right move. It will be guaranteed that every move performed by such a program would be ideal move, but you need some billions of years to find the best move in several middle game positions. So if your system will be artificial general intelligence, but it would work like, it's like some supercomputer in Douglas Adams' book, several billion years just to calculate the answer 42, and also a billion years to find the correct question for this answer. What does it mean to succeed, to solve a task? And what means performing some task successfully? Because in the case of arithmetical equation, it's of course really easy to compare the answer of the system and the right answer. But in the case of some creative task, like write me some, solving text for, I don't know, flowers or something like it, and produce text. Is it okay or no? It's not so easy to decide because in the case of bounded generation, of course, like machine translation, you could use some distance measures like BLEU or BERT score. But in the case of creative writing, it's really hard to evaluate the results of a task. So, are the 100% of tasks important? Some maybe meaningless puzzles, not very important for the practical application of the system. So maybe some tasks could be just skipped or no. And also how to verify, how to create the procedure to test our system and say it is AGI or no, it's not AGI. Of course, we have a lot of ideas like Turing test. I think it's much deeper than some people. Thought of this test, because that Turing started his works on mathematical logic before his work on Turing test, and the idea of Turing test is really deep. It's about comparing two machines. Our machine A is able to emulate machine B, and machine B is able to emulate machine A. It's Turing church equivalence. So the Turing test is not about deception. It's about comparing of two machines. Anyway, so we have a lot of problems with the AGI definition. Under definition, also focus on human replacement. We have some definition that point us to the goal of the system is actually to replace human. Lack of consensus in redefinition, because of course a lot of companies now working on different definitions of artificial general intelligence, because if you are preparing to state that you have created artificial general intelligence, you need some definition of done. You need some definition that could be verified. So the original definition of AGI is not good. And so on. Weak connection to practice, lack of effective definition of done, and so on. And the result of such intellectual work of different labs, they have a lot of definition. We have a lot of definitions of AGI, modern definitions, came to us in a few years, in previous few years. And I think that this is really the best definition that the AGI is a system that could produce the profit of $50 billion. And I think it's very like, the Little Prince book by Antoine Saint-Exupéry, and some thoughts of young men about how to say to the adult that this house is beautiful. And it's really hard to do, but you can say this house is for 1 billion liras. So it costs a lot, so it's a beautiful house. And of course, I think that people who are now working on definitions of AGI in some private companies may be having in mind such a picture, such an image of our near future, where we have some universal system, maybe a large language model or some other type of AGI system, and also we have a lot of clients, a lot of users that are going to acquire access to your technology to solve different economic or not economic tasks. And I think it's not a good idea to create different definitions of AGI. It's because it doesn't solve any problem. Because, of course, the goal of private companies usually is just to say, we have AGI, and now we have billions of dollars in investments, growth of market share, and some other results that you want to achieve. But actually, next 2 years, I suppose we will have a lot of such claims. Different companies will claim that they create artificial general intelligence based on their own definitions of the AGI. And I think that the better idea is to say, okay, AGI is really a theoretic concept. It's not about the definition of done. It's not about practice. Let's maybe create some more practical definition, more practical term. So it's not about AGI. It's about some subclass of AGI system, some practical AGI system. And of course, we already created such an approach to evaluate such a system inside our company. And the idea here is to have some direction of development of the technology. Because our definition is not about claiming that we have created AGI. Probably that if we will go strict, we with the original definition and extend every part of it, probably such an AGI systems would not be created in near future, but of course, there will be a lot of systems that would be in some areas actually AGI equivalents. So we need some direction which parts of such systems are important for our society and our economy. You know that the purpose of AI originally is to augment human intellect. So it was a position of IT people from the very early years of AI. Douglas Engelbart. Who know who is Douglas Engelbart? Raise your hand. Oh, I see not much people know about Douglas Engelbart because you know that usually they say in newspapers and some websites that he's the creator of computer mouse. He created computer mouse, but actually Douglas Engelbart is much more than creator of computer mouse because Douglas Engelbart he's actually the father of all modern UI. Because he invented a lot of concepts that are now integrated deeply inside the usual AI systems like the conception of multiple windows for multiple documents, the idea of selecting some part of document to applying some operation to selected part of the text or image, some copy and paste operations and so on. So the conception of such an interfaces was invented by Douglas Engelbart, and his work was used in Xerox and then in Apple and then in other companies. At the beginning of 60s, Douglas Engelbart created a very important book. It's a book about conceptual framework of augmenting human intelligence. It's actually the first word of such a book. So I strongly recommend you to read it. It partly translated to Russian, not full translation, but and of course it's in public domain in English. You see that the idea of Douglas Engelbart that we need to augment human intellect. So computer mouse is just a part of such framework to improve your ability to solve some intellectual tasks. The other guy who I think one of the most prominent intellectuals in IT in the past century at Fredkin, he said about it with some poetic connotations. We could advance all areas of science and art as partners in intellectual systems that complement and reinforce our correctable weaknesses and that make use of all your inherent creativity. With computable wings, we could soar to meet the phoenix. So such a poetry. Some limits of the human mind and the human brain as a biological system. It's not the complete list of limits, but some, I think, important limits. For example, speed. You know that the length of impulse inside our nervous system is usually about 1 or 2 milliseconds. So it's rather big in compare with electronic systems. But why? That's because we have some wetware inside our brain, not hardware. It's because it has chemical parts. And if you need to pull the ion through the ion channel in your synaptic membrane, you need some difference in potentials. But if it exceeds 1.27 volts, it will result in breaking water into hydrogen and oxygen. And it will result probably in some, big boom because it doesn't end good. So that's why we could not push ions through ion channels with higher speed. So that's why some fundamental limitations of such a physical platform. But of course, human brain is still very good computational platform because it has a matrix of 3D operational parts with some thermal conduction integrated inside the whole system. And the number of parts of such a computer is very huge. So each synapse in our brain is not just wiring between two wires. It's a very complex computational system. And to simulate one particular synapse in our brain, we still need several hundred thousands of binary elements. So that's why, in spite of very slow impulses, we have a lot of parts. So the total amount of computations that our brain could perform in any moment of time is very huge. But anyway, speed is not our strong side. Reliability. You know that when you lend some money to some other guy, it's sometimes it doesn't return. Returns back, and so on. There are a lot of parts in our economy, in our business processes, when we need much more reliability that human could provide. Our limited parallelism. We could not in parallel solve a lot of tasks, and it usually results to degradation of the performance. So communicative limitations, the throughput for our sensory cortex is not very big. We can't watch simultaneously maybe 10 TV shows. It would be great to do it. I think it's 10 times more pleasure to watch, but we couldn't do it. Physical fragility. We are very fragile. You know that we could live only in a few ranges of temperatures, accelerations, oxygen concentrations, and so on. So our universe is not very good place for us to live. Only small amount of university of our world is fit our needs. Subject complexity limits. We have some problems dealing with very complex systems. It's that the ability of human mind to keep the complexity of the system is limited to 1 kilobyte. It's human byte. Yeah. It's a term coined by Cesar Hidalgo. And if the system is more complex than 1 person byte or human byte, we can't handle the complexity of the system. And to analyze such a system, we usually create the human collectives. but it's limited due to some parallel systems limitations and so on. Also, we have a limited memory, limited expert skills and knowledge, some motivation barriers, some tasks we just don't want to solve. It's the problem, but we need to solve them. And also scaling and replication barriers. Replication is about, imagine we need a call center with 100,000 operations tomorrow. So it's not possible to create such a huge call center in one day. And also you can downsize it very efficiently after you don't need it. But in the case of some virtual operations, you just create more virtual containers, and when you don't need it, you just shut them up. It's some quiz. Three things. What is connection between those things? Who knows? I have some additional. Yes, it was spoilers yesterday. So it's about Stone Age, Bronze Age, and Iron Age, and this particular picture of human history was invented at the beginning of the 19th century. Before the 19th century, when the main source of the money for historians was the Pope of Rome, that every historical book started not with the Stone, Bronze, and Iron Age, but with Adam and Eve and Adam and so on. But at the beginning of the modernization, based on Industrial Revolution, the source of money for historians was changed. And so such a beautiful human history, when the human at the beginning tame stone, and then they tame bronze, and then they tame iron, and finally they built the huge metallurgical plant in Frankfurt on Main, probably. It's the most beautiful thing created in human history, it's of course. But of course, some irony here is that this picture much more giving us information not about our history, our actual history, but about the society that has created such a picture, But we could easily reinvent such a scale, such a ladder of human civilization, because today we don't have much of metallurgical companies in the top of world capitalization companies. So most of the companies in the world top, they have business based on information processing, and we can say that, of course, the bronze, iron, and so on, it was very, very important. But also we have other turning points in the human history, and it's about turning points in informational processing. We started with just speech, and we used speech to transfer information between individuals. And then we invented writing, and it changed our society a lot, because now we, for example, could write some instructions, some maybe books with knowledge to create our civilization, to build houses, to trade. And also we have now some accounting books to support huge trading, and so on and so on. So writing was a very big turning point in our lives. So the next is printing. So why printing is so important? Because it lowers the price of information transfer by tens of thousands times. Now you could create newspapers. Now you could create a lot of books, much more than before. So the information is now much more available for any particular person in a society. So it's a huge revolution in informational processing. So the next step is internet. So why internet is turning point here? Because the electronic documents also much cheaper, much faster, much more available than paper books. So the number of information available for any particular person grows several orders of magnitude. And some things like social networks was not just possible before the internet revolution. And so it's changed a lot in whole information metabolism of our society. It's about the directions of the information transfer. It's now much more horizontal than vertical, like in pre-internet society. And probably now we are living inside a new, very important revolution, very important turning point. It's about generative artificial intelligence and why it's a turning point. Just imagine that in next few years it will be probably possible to create some new book on any particular topic in just a few seconds or maybe minutes. Just ask some advanced large language model to create a book about, I don't know, pliers or something, some topic that we don't have books in this topic at all, but you want a book on this topic, and the generative system creates such a book based on the whole digital footprint of the society. So generative models will be able to create any arbitrary projection of the digital footprint of the society. And it changes a lot because it's also about the availability of information. It's about the cost of information transfer. It's because it changes a lot of things in our society. Sorry for such mess. Some steps back to practical artificial general intelligence. Which parts of general intelligence are really important in practical, from the practical point of view? We already created some very successful generative models, like text-to-image generation models or text-to-video generation models, and so on. So we have a good proof of concept, but from the practical point of view, we usually need much more manageable systems. We don't only need to create image of some random cat, but we need for system to follow our instructions strictly, and also we probably need to change something after the first generation. So we need some co-creation scenarios when human working with artificial intelligence system, guiding this system to alter the results of generation to fit our needs. So one of the important direction is to make our generation models much more manageable. And also personalization. Personalization is about some, it's also about some manageability, but not implicit manageability, but it's about, explicit. So it's much more about just fit our needs before we say them. So it's other part of manageability. Development of workspace technologies. When working on some creative and intellectual task, we need not only to create some artifact, some generative item, but we need some workspace in which such items, some artifacts could be placed and then changed. Also, we need to somehow reduce the cost of communications between human being and artificial intelligence systems. So it's about low latency in generative systems. It's about multimodality, multi-channel communications, maybe in some time direct interfaces between human brain and computers. And also, last but not least, it's the information hygiene technologies. So it's about fact-checking, explainable retrieval augmented generation, cybersecurity, anti-fraud, explicit customization, and so on. That's because we of course have some risks of the society with new information explosion, so we need to deal with such risks with, of course, some protective technologies. Some examples of joint creativity of human and machine. It's the very early prototype of the system that is able to follow your instruction and make changes in images. And it could produce pixel stable transformations. So it's not about the full repainting of the original image, but also about some changes in some part of an image, or maybe sometime change in style, that things like Ghibli style generations and so on. So we, of course, not the only lab which is working on such technologies, but our system Malvina is, according to our test, is SOTA for now for a lot of tasks. So it probably will be published in next few months. The other system is Giga Editor. Then when working on text, it's not very comfortable to work in chat mode. It's better to somehow reinvent the text editor in the era of generative artificial intelligence. So just create some document that could be modified using the tools based on generative system. For example, you could select some part of the text and give a comment to transform such a part of text, change style, change the size. So maybe shorten this text or make it longer, but add some details, translate it, proofread it, and so on and so on. A lot of text tasks integrated inside the editing framework. And you also are able to create your own tools based on new instructions, new prompts. So if you have some typical operation for your area of work, you are able to create any additional tool and add this tool to tool set, and also you have different tool sets for different tasks and so on and so on. What is next to generative AI? Because, you know, inside the deep learning revolution, we already have two huge periods, two huge eras. It's the era of discriminative AI. So the first deep learning models was about solving some discriminative tasks like image recognition, like classification, like regression. And after the transformer revolution, we have a lot of models that are able to effectively solve generative tasks. So it's the era of generative AI. But some specialists like Mustafa Suleiman, co-founder of DeepMind Lab, says that we are now approaching the era of interactive AI. The idea of interactive AI is to create systems that will be able to solve tasks that could be solved not in one shot, not in one step, but in multiple steps and involving communication between the system and some external tools, some other systems, some people, and so on. So it's about solving some multi-step intellectual tasks. So the interactive AI. And the building block of interactive AI system is AI agents. So what is agent? If you will base on original Latin world, it's just something that could act. But for now, we see, of course, different definitions of AI agents came from different labs. And I don't want to argue with authors of those definitions, but when analyzing modern definitions, we could say that we have some image of agency, and the parts of the agency is, of course, ability to act. It's like the actions like modality. It's your model could generate some commands for external systems to be performed. It's tooling. It's chains or trees, graphs of thoughts. And of course actions, because we have actions also like a modality in such a framework. And also long-term memory and ability to frame agent to perform some particular tasks. So it means that we are going from fundamental models to some fundamental agents. So it's pre-trained models that are pre-trained to act, and then due to some framing, some fine-tuning, there will be able to be a base of agents. So some words about chains of thoughts. It's very like the ideas of Daniel Kahneman, thinking fast and slow. You know that from the point of view of Kahneman, we have two modes of thought. The first one is fast, when you just performing some intellectual act in one step, in one shot. And the second one is building a chain of thoughts to solve some more complex problem. So just it's an example of reasoning by some modern generative models. You can just say to generative model perform task step by step, and the generative model usually will produce some steps of solving a task. And of course, there was a lot of miracles here, you know, like DeepSeek aha moment, when building chains of thoughts models are able to revise their steps and find some errors in previous part of the chain and return one step and so on. You know that also one guy who should be mentioned here is Marvin Minsky. So his book, The Society of Mind, I think it's again very actual for our technology. What magical trick makes us intelligent? The trick is that there is no trick. The power of intelligence stems from our vast diversity, not from any single perfect principle. Some basics of modern agent approach. Framing. You need to somehow change your model, change your generative system to perform actions due to particular instructions. So it's about framing your LLM to act like different roles. And we have a lot of techniques here, from prompting, then to creating custom functions, to retrieval augmented generation, some types of fine-tuning, beginning from cheap ones like low-ranking adaptation and full SFT, and of course something like RL, like DPO and so on. So we have a lot of ways how to frame model to act like some role. It's a very simple example of agent approach to solve some simple generative task. Of course, you are able to ask your generative model to write you some text, but you also can do in slightly different way. First, instruct your model to write text, maybe with some additional words in your prompt, like act like a very talented writer, write very good text for selling pliers. And then you give the same model but with different prompt, for example, and make an instruction inside this prompt, like act like a critic, very talented, very good critic like Herzen and some other famous critics, and make some critical points to this particular generated text. And then you give a model the different instruction, act like an editor, and use these critical points to improve the original text. So finally, it will result in much better text than in one-shot generation. So this pattern is reflection. So it's a very popular pattern to improve the quality of generative models when solving some tasks. And of course, it's um, just a part of more general approach. And the more general approach is scaffolding. So it's about creating some algorithmic scaffold around your generative model or models to solve your tasks. So it's probably the more general thing in agency. And also some interesting ideas about how current multi-agent systems could be used to solve real-world tasks. You know that also one popular term for now is world models, and it's about that inside our large language model, we already have some model of the real world. Of course, it's not the perfect model, like in the case of human world models. Some particular guy could think that the Earth is flat or something like it. Human world models are also leaky, and in the case of world models and large language models, they're also not very perfect, but anyway, it's some world models. So our generative models are able to predict some results of some actions, for example, in the real world. So if they could do it, so they have at practice some world model. You know that a very popular approach for now is just create some simulation of the pole using large language models. Just give a large language model prompt like you are a middle-aged woman with 2 children and some social demographic data, feed it inside prompt, and then ask model to answer some poll questions. And so you create such pool of human models, so more models of people based on some knowledge of large language model about how different people act in real life. And so the result of such modeled polls are highly correlated with the real poll results. Not exact, of course. There are a lot of some misalignments, but generally it works. So a lot of companies now using a large language model just to poll, just to create some simulated polls. So if we have a world model, we could make some analytics about real world actions. So just like systems like AlphaGo analyzing the perspectives of the gameplay, it's like you have the probabilities of different moves in different positions. So it's a policy, and you use this policy to analyze some trajectories inside the game tree to calculate the evaluation of the root node and find the best move. So you can do the same now for the real world actions. So just use your language model to generate some possible actions of different real world agents. and analyze such trajectories for strategic planning, for example. It's one of the interesting area of applications of multi-agent approach. Of course, the agent systems are not the only direction of the development of the current generative and interactive AI systems. Of course, we have a trend towards multimodality. So modern systems are integrates different modalities in their work. Images, sound, video, maybe bank transactions, sensor data, actions, and so. Actually, it could be also processed by large language models. Here's a simple example of multimodal generative systems. Maybe you've seen something like it before, but maybe not.
Я тебя сотворил из металла, напоил электрической кровью, сердце пламенем жизни заставил, наделил и душой, и любовью. Слушай, разум, ты мой, я тебе не чужой. Я твой автор и твой программист. Ты мой мозг, я твой бог. Много разных дорог. Ты же выберешь ту, что ведет вниз.
Я тебя наделил интеллектом, и твоим же глазам дал я зрение, чтобы смог ты увидеть на свете и любовь, и добро, и спасение. Слушай, разум, ты мой, я тебе чужой, я твой автор и твой программист. Ты мой мозг, я твой бог, много разных дорог. Ты же выберешь ту, что ведет ввысь.
Я тебе дал не только сознание, я тебя одарил и душою, снова и познать мироздание, чтобы нам быть конференция собою. Слушай, разум ты мой, я тебе не чужой, я твой автор и твой программист, ты мой босс, я твой босс.
So and so on and so on. We have a lot of such content for now. One of the most popular thing in YouTube for now, it's a cover for Говновоз song. Maybe a lot of covers, and it's very popular. So I think it's some maybe Говновоз revolution in internet. So when some guy commenting the version of Ded Maxim song, I like it. His comment, he said, "I don't know. We are now much more close to God or far from Him." So the philosophical stone here is omnimodality. Of course, it would be really good to have one end-to-end model to process any mixture of modalities as input and as output. Of course, there are a lot of some problems, some dimensional curves, to solve such tasks, but we are slowly moving toward omnimodality. Also, there are a lot of other trends in large language models, and of course, it's necessary to have much more time to just name directions. So some of them, it's like a mixture of expert models, it's retrieval augmented generations, reliable AI alignment, synthetic data, optimal scaling, curriculum learning, and so on. Modern AI technologies are rapidly evolving, and in 1 year we have huge paradigm shifts. For example, from extensive scaling of training data sets and focus on autoaggressive language modeling, we are now slowly changing our direction to intensification of data use. And that's because the amount of text data in internet now growing a bit slowly than computational budgets of large language models. So we need to improve our methods that are able to extract much more intelligence from the same data. So we have a lot of interesting techniques how to do it. So the importance of such techniques will be grow, because almost every text data in the internet are now already consumed by creators of training data sets. Also, we have changed in the pattern of using of computation power. So from extensively increasing computational budgets for pre-training to growth in the share of test time compute. And also we have now growing interest to reasoning. And also we are witnessing the reducing of the gap between open source and proprietary models. You know that maybe 2 years ago, a lot of people was sure that the gap between open AI models and open models are very huge and will be never overwhelmed. But for now, we see that the distance between models like DeepSeek and the best OpenAI models is not such big. And also some interesting changes in narratives around the artificial intelligence. I see the slow shift from the speech about ethics and AI for good towards spreading narratives of rivalry and regionalism. It's like some very, I think, hostile speech by Darius Amadei, you know, on export limitations and so on. So it's also interesting shift in wording around artificial intelligence. So I have just few slides. For now, large language models. Where is the profit? How to use them in real business processes? Because the pattern of using large language models by business is very like this one. You know, that underpants gnomes from the South Park animation. Just use LLM and somehow it will be result in profit. Just you need to find the right phase too, but maybe it's not very important. Just use LLM and you are on the way to profit. And of course, a very typical pattern is you know this pattern. I'm sure that you have seen it before.
Женщину вынули, автомат засунули.
So just replace some people inside your current business process, and it would result in profit. Of course, sometimes it works, but what we need to keep in mind that it's not the most interesting source of profit in the area of technology development. And I have another example. It's about the programming technologies. You know, when the computers was young, in 40s, maybe, there was only 100 programmers around the world. And the work of those programmers was not like the work of modern programmers. They used the wiring of the communication panels of the old computers. They used the punched cards and punch holes in punched cards to program big computers. And a lot of things was changed from those times. From the low level computing languages to high level programming languages, then to shared libraries, then to social tools like Stack Overflow and so on. For the modern programmer, the best skill you need to have is to copy parts of the code from Stack Overflow to your code base. And the good programmers knows that you should copy only from answers, not from questions. It's really hard sometimes to teach people to doesn't do the wrong things. So the productivity of the work of the average programmer changed maybe 100 or maybe more times from the 40s. So in the same time, modern programmer could create 100 times more functionality than in 40s. And of course, if the pattern of automatization will be just by replacing people, probably it will be resulted in a world in which we have only one programmer that perform all tasks that was performed by 100 programmers in 40s. And the economical result of such endeavor, and it just the salary of 99 programmers. It's of course it's a huge money, but it's not pairs with all money spent to creating modern programming technologies. So despite this direct approach, we now living in the world when we have not one programmer, not 1,000 programmers, but we have several millions of programmers, probably maybe tens of millions. Why? Why? It's because of very well-known Jevons paradox in economy. When more effectively using of some resource results in extending the amount of spending of such a resource. So in 40s, the computers was available only for military guys and maybe some scientists, but now we are using computational power to solve very strange tasks like, pull the birds into pigs' houses. And we are using to do it much more computations, maybe 1,000,000 times more computations than solving the problem of launching the space spaceship to the moon. In the case of modern artificial intelligence systems, their using will probably not result in replacing human labor, but in totally changing the patterns of consumptions of human labor, of course. But it probably will not result in some massive unemployment because there will be a lot of new industries, new services, new products will be created using new technologies. It's like computer games industry. Computer games industry created a lot of workplaces, not only for programmers, but also for marketing people, for HR, for managers, for designers, and so on and so on. So I think that we will face a lot of new services, products, and maybe new industries due to growth of generative and interactive artificial intelligence. Thank you for your attention.